Okay, welcome back. I've done this before. I've shown a very similar demonstration, but this one is slightly different. In the previous demonstration, basically, I had a motor here, a coil, and then a split ring here. Okay, so let me show you how this works. In the previous demonstration, I had this coil, and then these two metal pieces here, and then this ring in the middle is what's called the split ring. But instead of this piece right here, I had two magnets going this way, and then the magnets were used to turn this coil right here once I have electricity going through the coil. The only difference here is that instead of magnets here that I can adjust their distances, now I have an actual coil of wire here and then an iron bar. So the purpose of the iron bar is when I connect this to a power source, a power supply, there's electricity going to go through these wires, and that's going to create a magnetic field. The iron bar that connects this wire together, goes through here, will strengthen the magnitude of that magnetic field, and it will link it here, and it will exert a force on this. If I didn't have this iron bar, the magnetic field here will be weak, and it will not make it all the way to the front edge right here, you see. So it will not be able to turn this thing. So this iron bar is very important. So now I'm going to connect this here, this one, to the power supply, to the DC output of the power supply. Okay. And then the other end I'm going to connect to the other DC output. And then I can adjust the power here, the voltage source, right? And then this top two wires I'm going to connect to another DC output, and then electricity will run through there. And then the magnetic field created by the original one will exert a torque on this, and it will cause it to turn. And the fact that the split ring splits it in half, every half cycle it reverses the direction of the current. If I didn't have this split ring right here, if it was a complete ring, what would have happened? This would have just oscillated back and forth like this, right? It would have just oscillated and eventually probably stopped, but it wouldn't oscillate, but it wouldn't turn. So what you have to do, every half a cycle, you have to change the direction of the current, so that instead, when it's going this way, instead of coming back, you make it continue going in the same direction every time, okay? So now let's connect it that way, and then let's now connect the top to the DC output of this power supply. Okay? Okay, now I can adjust the current, I can adjust the voltage on the top, meaning make more current go through here, and I can also adjust the voltage going through the original coil, through the back coil, causing a stronger magnetic field. So I have a chance of adjusting both of them here and being able to tell the rate at which this is spinning. Okay? So now I turn this one. I have both of them on 1 volt right here. Let's see if this will turn. 1 volt. This one is not turning. So now let me increase the voltage on the top to 2 volts. Let's see if it will turn. So 1 volt on the back wires and 2 volts on the top going through here. The 2 volts, that was sufficient to get it started going. Okay, now let me change this back to 1. You notice that's not enough to get it going, and now let me increase the other one to 2 volts, the back one. Let's see if this is now enough. You see, so that one is not enough. See how it stops? Okay, so that means you need at least 2 volts on the top one, and then 1 volt on the bottom is still okay. So let's go back to the 1 and the 2. Now the other thing I want you to notice is if I try to spin it the other direction, it won't do that. It will come back and it wants to rotate counterclockwise. This has to do with the way that I have connected the power sources, right? If I change the direction of how I connect this, okay, now I connect it back, now it's going to rotate clockwise, right, from the top. So it has to do with the right hand rule and the way that the magnetic field from the top and the bottom, the way that the magnetic field is running and the torque exerted on the motor, right? So this one is rotating clockwise, and when I had it connected the other way, it was rotating counterclockwise. Okay, so the next thing let's do is up the voltage. So now I've got this one, the top one to 2 volts, and I can make the back one 2 volts. You can hear it. It's now starting to spin faster. Okay, now I've got both of them on 2 volts. This here, this is on 2. And then this one is on 2 volts. Now if I increase the top one to 3, starting to really spin fast. Increase the bottom one to 3. And then increase the top one to 4. Increase the bottom one, the back one to 4. So now you can see how we can create a very, very fast motor that way. 5. 5. And I'm already smelling it. It's probably too fast already. I smell 6. 6. You can see the sparks that are flying there. So I'm probably going to stop there because I don't want to burn out anything. Okay, so now you can see how adjusting the voltage of the back one and the top one, the front coil, will create different speeds, and I could monitor that speed, and I can create as fast as the speed that I want. This is how electric motors are made, by using magnetic fields. Okay, thank you very much.